solving rational functions graphically. Our objective, we want to use the intersection method to solve rational functions graphically. Let's recall what we already know. We know what a rational function is. It is a quotient of two polynomial functions. Because it's a quotient, that means we have a denominator, and we need to keep in mind that the denominator can never be zero. When the denominator is zero, the equation or the function is undefined. All right, as we know, because we've used this method in the past, the intersection method, where we say y equals left side and y equals right side, find the intersection or intersections, can be used to solve all equations, including rational ones. So we're going to do that here. All right, let's first do a bit of work with our asymptotes. So you want to graph y equals 20 over x divided by, we want to graph y equals 20 over x divided by 15 plus x. Okay, let's graph that. Okay, get this out of the way. Whoops, sorry, I'm getting a little bit loose here on my end. All right, let's graph this. Y equals 20 times x over 15 plus x. Okay, we can already see here, I got some things going on here. I definitely got a vertical asymptote. Now, it looks like I even have a horizontal asymptote. But there's my graph of the rational function. Does this graph have a vertical asymptote? Yep, looks like it does right there. Okay, looks like it does right there. I just read off question A. Does this graph have a vertical asymptote? And the answer is yes, it does. We can see it. Okay? If so, find its equation algebraically. Vertical asymptotes are found when the denominator is 0. So 15 plus x equals 0. Let's subtract 15. Let's subtract 15. And when x equals negative 15, that is the equation of the vertical asymptote. Let's check that. There's my graph. Whoops. Feel a sneeze coming on. Okay. X equals 15. X equals negative 15. Excuse me. And let's come in. We can come in a little bit here. We're way out there. There's the sneeze. We can come in here. There we go. Okay, let's go like that. Okay, let's put in here x equals negative 15. Sure enough, there's my vertical asymptote. There's it going down, and there's it going up. So that worked out just fine. Okay, letter B. Does this graph, in letter B, does this graph have a horizontal asymptote? Well, we saw it earlier, and we kind of think it does. Okay, so let's say yes here. We saw it. You can pull it back out again. Does it have a horizontal line that appears to be shaping the graph? And the answer is yes. And so what do we do with that? Well, we first make sure that our equation, the numerator and the denominator, are written in general form. This has the x, whoops. This has the x written second, so I'm going to put the x in front. I'll go like that for you. So I'll write the denominator with x plus 15, so it's in general form. X, highest degree of x first, constant last. And then I look at the leading terms, okay? And so I have 20 over 20 times x. 20 times x over x. Let's remove common factors. Well, that's a common factor, and that's a common factor. I have 20 over 1. Well, that tells me I have a horizontal asymptote at y equals 20. Right there. Okay, horizontal asymptote at y equals 20. Let's take a look. Alrighty, we got the vertical asymptote. I'm going to go ahead and take the vertical asymptote out of there. I'll put the horizontal asymptote at y equals 20. And you can see that asymptote. If we go to the right, the green, the graph is getting closer and closer to it, being shaped by that green line. And as I go to the left, the graph is coming down and it's being shaped by that green line. It's getting closer and closer to it, but it'll never touch. So I have both a horizontal asymptote and a vertical asymptote in this problem. Okay, let's solve them. Okay, got the same rational equation right up here. And the question is, algebraically determine the value of y when x equals 10. Okay, what does y equal when x equals 10? Let's put in 10 for x. And I always use parentheses when I substitute. 200 divided by 25 is 8. So when x is 10, y is 8. Let's use the graph to check when x is 10. Okay, go back to my graph. Okay, get out of here. There's the y equals, and let's put over here when x is 10. And right there we have the intersection. Right there's where they intersect. Let's change the color for you. Whoops. I gotta change the, okay, let's change the color now. There we go, let's change it to orange. Okay, where do they intersect? They intersect right there. When x is 10, y is 8. Correct. When x is 10, y is 8. There's your intersection method to check that answer. Finally, we're going to do this one with the graph only. Use the graph to find the value of y that give y, the value or values of x that give y equals to 5. So we want to know when y is 5, what are the values of what is the value of, or what are the values of x? Intersection method, y equals, y equals left and y equals right. And let's see what we come up with for the values of x that give a y of 5. Okay, so we're here. Okay, y equals, that's the right side. When y equals 5, that's the left side. And it looks like, well, we've got one here. The answer is 5 there. Do we have one on the left side? The answer is no. It's not going to ever, if the asymptote is above it, so it's never going to cross. So we only have one one x value that gives a y value of 5, and that's the x value of 5. So I'll come back over here. And we use the intersection method to determine that x equals 5 gives a y value of 5. So there you have it. How do we solve for, use the graph to solve rational functions.